Hi everyone, welcome back to Calculus. Today we are going to be analyzing graphs of derivatives, not graphs of derivatives. So what that means is we are going to be looking at either the function or its derivative and identifying characteristics of the other one. So let's write that out. Okay, so either you'll be given the graph of f prime, then you'll have to tell about f, tell characteristics. So given the graph of f prime, you'll have to tell me where f is increasing or positive or negative or has a relative max or min. The other thing that you'll need to do, let's see, if you're given f, not f, not like given f, let's erase that. Given f, you might have to tell me about f prime. Okay, so welcome to calculus. This is what makes it calculus. I'll ask you about f, but I'll give you f prime. Or I'll ask you about f prime, and I'll give you f. In pre-cal, you were given f, and you had to give characteristics about f. So that's the difference between calculus and pre-calculus. Pre-cal, we give you the graph of f, and you just have to look at it and tell me what's going on. Calculus, we give you the graph of f prime, and you're going to have to do some thinking to give and analyzing to give me the graph about f. So you'll take a minute, go ahead and copy down this chart because this chart is going to be crucial, and we're also actually going to add another row in a future lesson. So this chart's going to have 3 rows, and for right now, we're just going to fill out, in this lesson, we're just going to fill out this information. But this chart is something you're going to want to have super handy this entire chapter is going to be crucial. All right, so the first thing we need to do is we need to figure out when f is increasing, what's happening with f prime. So f is our original function, f prime is a derivative. So Delta Math does a great job. So I'm going to pull up Delta Math. And let's look at it because they do a great job of giving you animated pictures of this. So notice they've given you the graph of f and then values of f prime, because remember that f prime is the slope of the tangent line to f at any given point. Okay, so let's see. So if you notice, like at this part, if I trace the graph, let me pull this, trace the graph. Notice how the values of f prime change. So right now, all the values of f prime are negative as f is decreasing. And then when f changes to increasing, the values of f prime are all positive. And they stay positive until f starts to decrease again. When f is decreasing, f prime has negative numbers. And now f prime is 0. The graph changes to increasing. But f prime numbers, which I'm looking at right here, the f prime numbers are positive. And they remain positive, even though they get really close to 0, they remain positive until the graph of f starts to decrease. And once the graph of f starts to decrease, then those derivative values become negative. So we can take that and fill out our information here. When f was increasing, so when my function was increasing, go back to the beginning. Where was it increase? Okay. So when f increases from here on up, what types of values does the derivative have? What values do you see up here? So function increases, those values are positive. So when the original function is increasing, f prime is positive. Then when f was decreasing, pull that up again. When f is decreasing, so f is going to decrease until about -2, the derivative values are negative. Okay. Derivative values are, I'm going to abbreviate negative neg. Okay. When there's a relative max, what is the derivative doing? Okay, when there's a relative max, like right here. Here's a good example. Okay, so a derivative, looking at these values, there's a relative max right there. What happens to the derivative? Derivative is positive, then it changes to negative. So to have a relative max, remember f has to increase and then decrease. Well, if f has to increase and then decrease, then f prime has to be positive and then negative. So for there to be a relative max, f prime has to change from, we have to see the change, positive to negative. For there to be a relative minimum, we have to see a change negative to positive. Okay, and then let's kind of look at how this graph relates. Okay, so the graph of f is increasing. So f is the black graph, f prime is the red graph, f double prime was the blue graph, but I whited it out because we're not looking at that today. So when the black graph is increasing, so up until this, the red graph is above the x-axis, positive right here. So I'll write that down. So when this black graph is increasing, going up, the red graph stays positive. And then as soon as the black graph changes to decreasing, the red graph, and it's decreasing all the way until we get to this point, the red graph is below the x-axis, negative. And then when the black graph, the first original function, is increasing again, the red graph is positive again. Now, a critical value could be a relative min or a relative max. We'll have to do further tests to figure out exactly what that is. But a critical value is a place on f that could have a relative min or a relative max. But what that would look like on the derivative, it would be 0 or does not exist. And we'll spend more time with critical values later, but for right now on your chart, you just need to know that it would be a critical value for f wherever the derivative is either equal to 0 or it doesn't exist. Okay, so let's look at some examples like what you'll have. First one, the differentiable function of f is shown below. So my advice to you guys is go ahead, because you're working with the graphs of f and f prime, make sure you pay really close attention to what graph they give you. And even though it's labeled, I like to make a note to myself, this is the graph of f. Okay, shown below on the domain from the open interval from -9 to 9. Determine which statement is true regarding f prime of 6, f prime of 1, and f prime of 3. So what they're wanting us to do, if I kind of scroll down, they're wanting us to compare and see which value is larger, f prime of 1, f prime of -6, and f prime of 3. So the derivatives are the slopes of the tangent lines. no space. Okay, so I'm going to sketch a tangent line at -6. So right here, looks like there's a positive slope. At x equals 1, looks like we would have a negative slope if we were to sketch in a tangent line. And then at x equals 3, ooh, that looks like it would be kind of like 0, right? Slope would be pretty close to 0. So it looks like they have us rank them, yeah, smallest to largest. So if I rank mine smallest to largest, it looks like the smallest would be the one that's negative. So f prime of -1 is the smallest, or f prime positive 1, and then because it's negative, and then this 0 slope or 0 tangent line would be f prime of 3, and then the greatest slope would be f prime of -6. So you have a couple where you do have to compare the slopes of the tangent lines at each points. Then you'll have some where you have to determine all intervals on which f is decreasing on the closed interval. So this time they gave me the graph of f prime. So they did label it f prime, but I'm also going to make a note to myself, hey, Ms. Honeycutt, this is f prime. And so determine all the intervals on which f is decreasing. So I want f to be decreasing. But I'm not given the graph of f, I'm given the graph of f prime. So f is decreasing whenever f prime, might want to refer back to that table, whenever f prime is negative. Oops. F is decreasing whenever f prime is negative. When a function is negative, it'll be in quadrant 3 or quadrant 4. So I just need to look for those parts. So let's see, it would be negative here, and f prime is negative here. So those intervals, so from -9 to -8, and from -1 to 5. So I can say, I need to make sure I'm answering my question, that f is decreasing on the closed interval from -9 to -8, or also from -1 to 5, because I have the graph of f prime, and f prime is negative. There is my solution. I know that f is decreasing on those intervals because that's where f prime is negative. Let's try another one. Now we have the graph of f prime. Again, f prime. And this time I'm going to be looking for where graph is, for where f is increasing. So I want to know, when is f increasing? But I don't have the graph of f, I have the graph of f prime. Well, f prime is increasing whenever f is positive. Sorry, f is increasing whenever f prime is positive. So f is increasing whenever f prime is positive. And the graph is positive, or an f prime is positive when that's in quadrant 1 and quadrant 2. So that would be this part of the graph, right here. And I just list those x values. So I would say that f is increasing on the closed interval from x equals -9 until x equals -2, close bracket, because f prime is positive. Now I want to know where f has a relative maximum, but I'm given the graph of f prime. So I'll refer back to my chart. F has a relative maximum when f prime changes from positive to negative. So positive meaning that the graph would be in Q1 or Q2, and then all of a sudden it changes from being Q1 and Q2 to quadrant 3 or quadrant 4. All right, so, and again, this is a graph of f prime. So f prime is positive, changes to negative, so right here. And then it doesn't ever change from positive to negative again. It changes from negative to positive, but not positive to negative. So this would be at x equals negative 6. Then we want to know all the local extrema given the graph of f prime. So that's asking for relative maximums and relative minimums. So let's look for relative max first. So f would have a relative max, according to my chart, when f prime changes from positive to negative. So let's do that part first. Positive to negative. So being from positive to negative happens right here at x equals negative 1. And then it doesn't change from being up here to down below again. Then if I want to find f to have a relative mid, that would happen when f prime, according to my chart, would change from negative to positive. So negative being in quadrants 3 and 4, and then positive would be quadrants 1 and 2. All right, so is there anywhere where my graph goes from negative to positive of f prime? Right here at x equals 8. Now, since the question asked for the local extrema, that means that they're wanting relative maximums and minimums all together. So I would enter as my answer x equals negative 1 and 8. Now we're looking for critical values, and I think that's it. Yeah. All right, critical values. Where does f have a critical value? So according to my chart again, f has a critical value whenever f prime either does not exist or equals 0. Now, I do on my graph, I've got these open circles at the endpoints, but I'm only looking on the open interval, so I don't have to consider these endpoints because they're not included in what they're asking me about. So now I just really need to look for where the f prime, graph of f prime is equal to 0. So that would happen here at x equals negative 7, at x equals 0, and at x equals 8. So I would type in x equals negative 7, 0, and 8.